management, which is offered by our colleagues from University of Houphouët-Boigny in Ivory Coast, under the leadership of Prof. Soro. It's a pleasure on our side to welcome the team of Prof. Fatogoma Soro for this second day. Nous apprécions en fait votre participation et votre leadership sur ces modules et nous espérons que ça va avoir un impact positif sur les participants pour cette seconde journée et peut-être pour la troisième et la quatrième journée. Encore une fois, vous êtes les bienvenus pour commencer à donner les modules que vous avez préparés. Prof, soyez les bienvenus.
Merci beaucoup. Okay. Okay, merci. I just want to find anyone. Hello. Can you
hear you? We can hear you, though it is the voice is still very low. Prof, go ahead, please.
And now, how is it?
It's fine. It's fine.
Great, great. Okay. So welcome to the second session of this module on Abiotic and Biotic, that means pest and disease management in crop, fish, and livestock production. Yesterday we have the session 1 about crop abiotic and biotic stress, and today we start with the livestock, and tomorrow we're gonna have the one on aquaculture and fishery, and for the last day it's gonna be for poultry farming, and we'll have a demonstration of an app for the pest and disease users. So thank you. Now I'm gonna give the floor to my colleague, Dr. Akwatou Bertin. He is a specialist of livestock, let's say plant animals. Okay. Animal biology, yeah, specialist of animal biology, and I will give him the floor so that he can introduce himself and start the presentation. Thank you.
Okay, thank you, Professor Soro, for giving me the floor. Thank you to everyone. Thank you to all of you for spending your time to participate to this talk. I will start by sharing my screen. I don't know if you see my screen.
Yeah, we can see it.
Okay, thank you. So this second section will deal with climate-sensitive pests and disease in livestock in sub-African, Saharan Africa. This talk has been prepared by a team composed of Asovi Bro, Guy Mathieu, and myself, and assisted by Professor Soro. The content of this talk is organized like this. we'll start by presenting the communication objective and expectation, followed by a short introduction. And
Presentation mode.
Prof, but please put it on presentation mode so that it's a bit
presentation mode. Okay. See. Okay. It's okay?
Oh, yes. Yes.
C'est bon.
It's okay? Okay. So we're talking about the content of the communication. We start by showing the communication objective and expectation, followed by a short introduction. And after that, we'll go through 4 subsections. This first subsection will talk about an overview of climate change and livestock production. The second subsection will deal with climate-sensitive pests and disease in livestock production. And in section 3, we'll present the impact of climate-sensitive pests and disease on livestock productivity and rural livelihood. And we'll end our talk by section 4, we deal with management strategies and climate-sensitive threats. Sorry. Okay. The objective of this talk is to understand the specific climate-sensitive pests and disease affecting livestock. The expectation is that by the end of this session, we should be able to explain the concept of climate-sensitive pests and disease in livestock production, identify the way climate change influence the spread, intensity, and distribution of both pests and disease, explore the impact of climate-sensitive pests and disease on livestock productivity and rural livestock, and learn about adaptive strategies to mitigate the effect of climate-sensitive pests and disease on livestock. I know you are many to be connected to this communication. As Professor Soro said, I'm a mammalogist. I've not really deal deeply with livestock, so I will invite those who are important knowledge on this topic to share their knowledge during this talk. So you are welcome, and I really want this communication to be very participative. What was said, I say in introduction, sub-Saharan Africa population growing faster, yet it has the lowest average annual per capita consumption of livestock products. Globally, livestock account for 40% of agricultural PPT and employing 1.3 billion people and supporting 1 billion of world powers. Main constraints to livestock productivity in sub-Saharan Africa are diseases, inadequate breeding policies, and poor management. In subsection 1, which deal with overview of climate change and livestock production, we'll see in first point, livestock system in sub-Saharan Africa, the impact of climate change on livestock, and the impact of livestock production on climate change. I hope that I'm not, I don't go quickly. Is it okay? If it's quick, let me know.
It's okay.
So far,
It's okay.
so far it's fine. I'm very happy with your path.
Okay. We go ahead. Livestock system in sub-Saharan Africa. Categories, we see, I represent the categories of livestock in sub-Saharan Africa, the livestock system management in sub-Saharan Africa, and the key challenges in livestock system management. Note that the main categories of domestic livestock in tropical Africa are large ruminant, cattle and camel, small ruminant, sheep and goats, and non-ruminant grazing animals, ACMs, and us. But the third category, we will not deal with the third categories today because this category will be treated tomorrow by my colleagues. Large ruminant, beef and dairy production are crucial in many parts of sub-Saharan Africa. They are also a key sources of wealth and social status, especially in pastoral communities. Concerning camel, they are bred as livestock in many countries around the world for the production of meat, milk, and wool or liver. Also for sport, tourists, and many places, also for transportation. Concerning small ruminants, those are especially important in arid and semi-arid regions like part of East Africa, I mean Somalia, Southern, and the Sahel. In those pictures, you can see sheep and goats as small ruminants. Livestock system management in sub-Saharan Africa. This is an overview, not that livestock system in sub-Saharan Africa are essential for food security, income generation, and cultural practices. I don't know if someone wants to share an experience of cultural practices in livestock management. Okay, you can also note that effective management of livestock is very crucial for improving livelihood, enhancing food security, and promoting sustainable agriculture. A livestock system are also influenced by environmental, economic, and social factors. The classification of livestock management system is based on several criteria. And based those criteria can be summarized like this: integration with crop production, animal-land relationships, production intensity, the type of products, milk, the size and value of livestock holding, animal movement pattern, type of breed of animal, and market integration and economic specialization. So based on those criteria, 4 systems are defined. The first system is the pastoral system. It's found in arid and semi-arid region, Ethiopia, Kenya, Chad, and Mauritania. And this system requires effective mobility, disease control, and water management. The second system is agro-pastoral system. It's a mixed system with both livestock and cross farming. This system is more developed in Nigeria, Tanzania, and Uganda. And in this system, we have a diversification of income and improved soil fertility. The third system is intensive system that we found in urban and peri-urban areas. Its characteristic is an higher input, feed, veterinary care, and it's vulnerable to disease and market changes. And the last system is transient system that needs seasonal movement across region. It's a mix of pastoral and agro-pastoral practices. Concerning the key challenges in livestock system management, that life system in sub-Saharan Africa face a wide range of challenges that affect their productivity, sustainability, and resilience. Those challenges are climate change, disease management, feed and nutrition, and land degradation. Concerning climate change, it's a period when the area is highly vulnerable to climate change with increasing variability in rainfall pattern, more frequent drought, and extreme weather event. You can see in the top image, people protected with umbrella and animal in the heat. Those changes can lead to reduced pasture availability, water scarcity, and increased livestock mortality. Concerning disease management, disease like foot and mouth disease, African swine fever, trypanosomiasis, and Newcastle disease are significant concerns. And effective disease surveillance and control systems are essential for preventing outbreak and ensuring the health of livestock. For feed and nutrition, note that inadequate feed supply, especially during dry season, is a significant concern. Livestock often rely on low-quality pasture and crop residue, leading to poor animal nutrition and productivity. The development of improved forage species and feed management practices is crucial. Land degradation, overgrazing, deforestation, and poor land management practices contribute to land degradation, reducing the availability of pasture and impacting the long-term sustainability of livestock system. Here I choose some images to better show what I just explained. All those fit and challenges are summarized in these images. We have the socioeconomic factors, climate change, disease management, feed and nutrition, and land degradation and market access. in the topic of impact of climate change on livestock, I show the heat stress, the biodiversity loss, food security, and water scarcity. But increased body temperature will cause production loss in livestock and impact on their ability to maintain normal function. You can see on this image an animal facing body temperature. Climate change and livestock loss. In this topic, we have that the risk of species extinction increase with every degree of warming, and the risk of livestock loss are context specific, but higher in environments that are already host. So when the environment is naturally hot, the risk of livestock loss is higher. Selling crops on grassland, not that climate change can improve or deteriorate growing conditions in different regions. It can favor the advent and invasive species, plants and animals simultaneously. Climate change can also impact food security. Agriculture is very sensitive to weather and climate because the effect of climate change on agriculture will depend on the rate and severity of the changes, as well as the degree to which farmers and ranchers can adapt. So to better face climate change, we need to have farmers that are very prepared to face these changes. Concerning water scarcity, not that the natural water cycle and the water-related components, including livestock, all affected by climate change. What about the impact of livestock production on climate change? We have greenhouse gas emission, land use, enteric fermentation, manure, and processing and transport. Let's go with greenhouse gas emission. The primary livestock greenhouse emission, we have carbon dioxide, we have methane, nitrous oxide, and we have the contribution to for each in the anthropogenic gas, greenhouse gas emission. Yeah, the methane represent 44%, the nitrous oxide 29%, and the carbon dioxide 27%. In this figure, you can have a representation of the global greenhouse gas anthropogenic emission. As I said, you can see the contribution of each component. In this picture, you can see the global greenhouse gas emission by livestock species. We have beef cattle, dairy cattle, pigs, So the contribution depend on the type of livestock species. Concerning land use, not that arable land increasingly converted to livestock management sites. And agricultural land covers about 38.5% of global total land area, which consists of 28.4% arable land and 68.4% permanent meadow and pasture. Agricultural land use change in relative to two concepts: profit per unit and profit per unit of land and opportunity cost. What is the case of enteric fermentation? Note that livestock contribute to 44% of the world's anthropogenic for emission through the normal digestive process, called enteric fermentation and manual management. And enteric fermentation and manual account for 80% of 52 agricultural emission sources. For manual, livestock manual release H4 and nitrogen gas. Estimated global methane emission from manual decomposition is up to 70.5 million tons of CH4 per year, and manual must be properly managed to reduce its impact on the environment. In the top image, we have a traditional way of managing manual, and the last image, a modern method for management of manual. Processing and transport. More than half of energy used in confinement system is for feed production, including seeds, herbicides, pesticides, and machineries. Energy use depends on the type of livestock system and the scale. If we are dealing with small scale or large scale livestock system. So this slide handles subsection 1. I don't know if I need to continue, or if we can ask for some question, some contribution.
Yes, Prof. I think maybe you allow a few, like 2 or 3 comments or questions from anyone. Then we can proceed.
Okay.
So participants, anybody can ask any questions, or you can even just give comments to enhance the discussion. Thank you.
Hello?
Hello?
Yes, my question is very simple. Are we getting the PowerPoint presentation after this lovely, vital presentations?
Yes, Aban, you'll get the presentations. The professors say that they need to do the training and then clean them up a little bit, and then they will share. So we shall send them to you. Yes, yeah.
Yes, and because I'm calling from the University of Namibia.
Okay.
School of Veterinary Medicine, and I'm also a a student, how to call it, a promoter or a...
We call them advisors, students.
Yeah.
Or
Okay.
advisors. Advisor or mentor.
Yeah, mentor. And also we work with the community-based organizations where we actually also use bush. We are in a bush encroachment landscape, and we use this bush encroachment as a livestock feed, animal feed also. I think maybe I think it's a part of the climate change also, because we used to thin the bushes, and then this substrate we use for mushroom production also, for food security. I just wanted to introduce myself like that.
Thank you, Aban. Is there anyone else who wants to say something before Prof. Batin can continue?
Hello, my name is Steve Lecook from Kenya. I
Go
saw
ahead, Steve.
I saw the from LinkedIn. This where I found the presentation, the the Zoom presentation, and I decided to join. And
It's okay. Proceed, Steve. Now I've muted him. Sorry. Yeah.
okay, so I've just seen a very interesting topic on gas emissions from ruminants. And currently in Kenya, there is a campaign on mass livestock vaccination, which I cannot say our livestock are being vaccinated because we are trying to reduce the emissions, but there is from the public, there is a feeling that we might be vaccinating livestock because we tend to reduce emissions. And my question is, now that we are not sure whether the vaccination is about emissions, is there any vaccine that's available which maybe can be used to reduce emissions on ruminants? Thank you. Now that I've seen this from the presentation, that they are actually the highest contributors of climate change in terms of gaseous emissions. Thank you.
Thank you, Steve. Prof. Batin, can you maybe that's at least a question. If you have any answer for him now.
I'll try, and I feel that if someone has a good response, it can also help. But I think that vaccination can't only reduce gas emission. We also need to deal with the kind of pasture and some other things, but the vaccination can solely solve the problem of gas emission. Maybe they choose to privilege the vaccination because it can solve many other problems.
Okay, thank you, Prof. Steve, are you satisfied with the answer?
Thank you, Prof. I can't say I'm satisfied, but I just wanted to know if there is a vaccine for reducing emission of gases from ruminants. Is there one yet?
Hello?
Okay. When preparing this talk, I find some information about vaccine, but right now I can't confirm that there is a vaccine unless someone is informed about this.
Certainly.
Okay, Prof. Thank you for the, yeah. I think Steve, what he's saying is he's also not yet aware about that vaccine. So I think
Yes.
maybe we need to investigate further to find out.
Thank you.
Yes.
Thank you.
Yes.
Can I come up with another
Say
question?
something?
Yeah, regarding the climate reduce of methane or whatever, I want to know whether we can incorporate in livestock feed. Maybe if there is some ingredients we can also, because we can, which the farmers can also include in their feed, maybe to reduce the gas. I want also to know that.
I leave that to Prof. Yes.
Hello?
Yes.
I'm not sure I catch your question.
The question, I want to know whether if we manufacture our own livestock feed, is any ingredients which we can include or incorporate in our feed to reduce the gas?
Si, quand on va préparer nos propres aliments de bétail, est-ce qu'il y a des ingrédients qu'on peut mettre dedans, ou bien des liants, ou bien des choses comme ça, qui peuvent faire que les réductions, les gaz seront réduits, l'émission des gaz sera réduite?
Okay. Professor was explaining very the question. Yeah, I think it's possible. We are going to explore with your proposition, but I think it's possible because as far as I'm concerned, I think that the problem is due to the fact that we have industrial livestock management. But in traditional area, I think that they don't have this problem. So it's the same thing like human. You know, the food human people eat presently, manufacturing food, cause problem of belly. I think it's practically the same thing. So industrial food usually lead to this kind of problem situation. So I think that if you want to reduce gas emission, we need to better prepare the food for animals. So in this context, it's not excluded, but we include local material in the food.
Okay, thank you, Prof. I think the discussion can continue on the chat. Let Prof continue with the presentation. Thank you.
Okay, thank you, Davis. So now we are going to deal with subsection 2 concerning an overview of climate change and livestock production. 4 points will be addressed. The first is disease influenced by high temperature and humidity. The second point, the disease associated with drought or overcrowding. The third point is a disease with seasonal peaks. And the last point, seasonal impact on climate sensitive pests and disease on livestock production. Concerning disease influenced by high temperature and humidity, we have dermatophilosis, whose hosts are cattle, sheep, goats, horse, and the pathogen is Dermatophilus congolensis. The symptom are skin lesion, paintbrush lesion, fever, pneumonia. The transmission is direct contact. Also in a contaminated environment and vector-borne like stakes. Climate sensitive factors are wet and humid weather, increase the incidence. The rainfall and humidity can cause the spread of the head. We have the Rift Valley fever, whose hot sheep, goat, cattle, and camel. Those animals develop zoonotic disease, and the pathogen is the flavivirus reference Rift Valley fever virus. The symptoms are fever, anorexia, abortion, and in pregnant animals, and hemorrhagic manifestation. The transmission is due to mosquitoes and contact with infected foods. Climate sensitive factors are increased rainfall and fooding-related mosquito breeding condition. Another disease is non-peace kind disease, which affected cattle, water buffalo, and the pathogen is Capripoxyvirus lamplitis pos. The symptoms are nodular lesion, fever, reduced milk production. The transmission is blood feeding arthropod, mosquito, ticks, and lice, and direct contact. Climate sensitive factors are warm, wet climate, next vector population. We also have sheep and goat posts, which affect sheep and goats. The pathogen is sheep pox virus and goat pox virus. The symptoms are skin lesion, fever, systemic respiratory distress, and the transmission is direct contact, aerosol, contaminated formula, formite, and mechanical vectors. The climate sensitive factors are warm and wet conditions facilitate outbreaks. We also have gastrointestinal helmet, which affected cattle, sheep, goat, pig, and poultry. The pathogen are nematodes, cestodes, and trematodes. And the symptoms are weight loss, diarrhea, anemia, subclinical productivity loss. The transmission is ingestion of larvae from contaminated soil or water. And the climate sensitive factors are warmers, winter climate increase survival and effectivity of eggs and larvae. We also have the tick-borne disease, which affected cattle, sheep, goat, and horse. The pathogen is Protozoa viruses, and the symptoms are fever, anemia, lethargy, jaundice, neurological symptoms, and viral. The transmission is tick bites, direct blood contact, and direct blood contact. Climate sensitive factors are warm temperature, expand tick habitat, seasonal rainfall that affect tick densities. What about disease associated with crop or overgrowing? We have contagious bovine pleural pneumonia. The host is the cattle, and the pathogen is Mycoplasma equidus. The symptom is fever, coughing, nasal surge, labor breathing, and the transmission is respiratory droplets and direct contact. The climate sensitive factors are warm, humid climate that favor survival, drought, and overgrowing exacerbate outbreaks. The horse is herbivores and cattle, sheep, goat, and horse. Hello?
It's Colleen.
Hello. Okay, I was talking about anthrax. The horse is herbivores, and the pathogen are Bacillus anthracis. The symptoms are sudden death, fever, dark non-clothing, blood from orifices. The transmission is due to injection, inhalation of spore, contact with contaminated soil or water. And the climate sensitive factors are warm, dry climate that favor spore survival, and heavy rainfall can reintroduce a spore. Now with trypanosomes who affected cattle, sheep, goat, and horse. And the pathogen is Trypanosoma convalescens. The symptoms are fever, weight loss, anemia, infertility, and chronic disease. And the transmission is sexual flight, mechanical transmission. Certainly, the sensitive factors are high humidity and warm temperature, but increase testis flight habitat and drop after vector distribution. What about disease with seasonal peaks? Of the blue tongue, warm and wet conditions favorable to meadows. The horse are sheep, primary, cattle reservoir host, and wild ruminants. And the pathogen is blue tongue virus. The symptoms are sheep, primary, cattle reservoir host, and wild ruminant. And the transmission is due by biting needle and mechanical transmission. Climate sensitive factors are warm, wet conditions that favor this, and climate changes expands disease region. What about the seasonal impact on climate sensitive pests and disease on livestock production? We have in the middle the seasonal impact on livestock. Ascending temperature, we have increased infestation that prolongs pathogen survival and vector-borne disease. Assigning the precipitation at favorable condition for pests, waterborne pathogen, and drought stress. The climate change extend pest activity, and new disease can also emerge and a geographic area can spread. So this figure is summarize all those climate sensitive pest disease and livestock production. David, I've just presented the subsection 2. If you can do the same thing, if there are some contribution, some question, but for the section 2, I'd say I'm not very autonomous with this section. So if some participants have more to say about section 2, they are welcome. Hello? Hello, can you hear me?
Yes, we can, Prof.
Okay. So I was saying that for section 2, it will be, I will appreciate contribution for participants because this session, I'm not very happy with. I'm not very autonomous.
Yeah, I'm Tembinkosi from the University of Zimbabwe. I was just thinking when you were making a presentation on the subsection 2 to say, when we are looking at the ecology, the natural selection, you know, ecology involves the diseases, and also it involves the natural response from animals. Let's look at the natural setup where you have wild animals, the kudus, the impalas. No one is vaccinating those, but they respond naturally to diseases, and the offsprings that come out of that they resist the diseases and the stuff. So I think human intervention, when we are coming in with the vaccines and so forth, that's why we have pesticides and the disease resistance coming in. I don't know what's your comment.
I don't know if I catch you very well. You were saying that environmental condition can also have a role in disease emergence. Am I right? I didn't catch you.
Yeah, something along the lines. As long we have human intervention, that's when we have emergence of new diseases, disease resistance, pesticide resistance. I was linking this to ecology to say in an ecological system, you know, natural selection, you got wild animals, impalas, kudus. No one is vaccinating those. But
Yeah.
what's happening is they develop the immune system against any new threats that are coming from the environment.
Yeah, I get. Yeah, I think you are right because yeah, when it's like the system of immunology. You know, even in human people, you can see a footman eating anything in the road. You won't feel sick. But we guys, we think that we are normal people. If we eat the same things, we can feel sick. So I agree with you when you say that ecology and is the importance in this context. And we can also note that in natural area, animal eats, good food, good, strong food. So this can also lead to the strong of the health, the health. So yeah, I think that we are right on this side because even for chicken, for example, breed chicken, when you let him in the area and this chicken eats everything fine, people said that this chicken is more resilient than those who are breeding. So yeah, I think that you are right. The environmental condition can also contribute to animal health.
Hello. Hello. Yeah. Can I contribute?
Yes, Prof. Lamptey, please. I think, yeah, please go ahead. Yes.
Please, Prof, can we go to slide 42? Prof.
Slide
Apatu.
42.
Yeah, 42. Yeah, here, this one. Climate sensitive factors.
Yeah.
The second one, you said seasonal rainfall affects tick densities. If you can write it like the way you have written this one, warm temperatures expand tick density. That's clear. So is it low rainfall? Is it heavy rainfall which affects the tick density? What does it do to the tick density? Does it reduce it? Does it increase it? So I think if you can break it like the way you have done the first one, it will be good. I hope you understand what I'm saying.
It's a bit quick. I didn't catch you.
Oh, sorry. Let me take my time. I'm saying that if you look at the first factor, warm temperatures expand tick habitats.
Yeah.
If you can do similar for the second one. Because when you say seasonal rainfall, I don't know what you mean. Seasonal rainfall only means the changes. But if you can write it the same way you wrote this one, like low rainfall decreases the tick densities, or high rainfall decreases the tick, just like that one.
So
slide 45. No. I don't know the answer. I'm asking you to put the correct answer.
Okay.
Yeah. Instead of just saying seasonal rainfall.
Okay.
Then slide 45. Slide 45.
45. Yeah.
Is it 45? With a place where you say that climate change expands the disease regions. Is it 44? Maybe it's 44.
44. Okay.
Yeah, maybe. You said that one, you said climate change expands the disease regions. I missed the number. I thought it was 45. No, I think we have to go forward. It's in the 40s, I think. Keep going. Yeah, keep going. Yeah. 46.
So it's 46.
46, yeah. Climate change expands the disease regions. If you can break it down, just like you have done the first one. You see, the first one, you say warm, wet conditions favor midges. So it's clear. I know that high temperature and then heavy rainfall will favor midges. But when you say climate change expands the disease, I don't know which factor to consider. So if you can break it down similar to this one, I think it will be nice.
Climate change expands.
Climate change expands disease regions. Is it an increase in temperature which expands the regions? Is it a decrease in rainfall which expands the regions? So if you can write it the same way, the first one is okay. If you can write it the same way you've written the first one, I think it would be nice. Am I clear? Hello?
Prof. Batin, are you there?
Did you get it? Did you understand what I said?
Yeah, I get it. I get it. Yeah.
Okay. Okay. Thank you.
You're welcome. Thank you again. Okay, thank you. Thank you again. Okay, another contribution.
Prof. Batin, if there are not any other contributions, we can proceed.
Okay, thank you, David. So now we deal with subsection 3 concerning impact of climate-sensitive pests and disease on livestock productivity and rural livelihood. Now, here we deal with 2 points: the impact of livestock and the economic and social impact. We just go through with figure. We have 4 points: the vector habitats, the farming practices, the frequency of outbreak, and the immune system weakness. For the first aspect concerning vector habitat, we have the expansion of vector habitat and new disease in highland region. For farming practices, we have the brooding around limited resources and the migrating herds. For frequency of outbreak, the accelerated life cycle and with a favorable breeding condition. The last point concerning the human system weakness, we have stress from drought and extreme heat. And all those aspects have an impact of climate change on livestock. In natural conditions, all these aspects can be explained together. That this figure is a summary of all different aspects, such as vector habitat, farming practices, frequency, outbreak, and human system weakness. Concerning the economic and social impact, we have food security and the increased healthcare cost and increased risk of zoonotic disease. Note that climate-sensitive disease can reduce livestock output, harming farmer livelihood. Now, concerning food insecurity, we have the feed to livestock, the health, the mission, essential and food sources and nutrition. increasing healthcare costs. But first, treating livestock disease incur high cost, burdening farmers financially, because it's a lot of money that they have to spend to take care of the health of animals. And the increase of risk of zoonotic disease, note that some livestock disease pose human health risk, straining medical resources. So for section 3, I just reduced my took to those 2 slides that resume the impact of climate sensitive pests and disease on livestock productivity and rural livelihood. At this stage, it would be best to share knowledge with colleagues who have worked deeply with this topic related to impact of climate sensitive pests and disease on livestock. So for section 3, if you can have contribution question. So I don't know if some of you have deal with this topic. I mean, impact of on livestock, impact of climate change on livestock, and if we have a specific experience to share.
Yes, participants, if you have any experiences from your countries, you can feel free to share.
Yes, for instance, here in Zimbabwe, the last 2023 to 2024 rain season, we experienced a severe drought, climate change induced a drought. As a result, we lost quite a large herd of cattle countrywide. To an extent, during this season, with very good rainfalls, but now we don't have, we have very few livestock left, and so now we've got loads and loads of pastures because we don't have much of our animals left. Thank you.
Okay, thank you. Really invite you to share experience because here in Cote d'Ivoire, we don't really face climate change because it's not in a arid zone. So if some colleagues coming from arid zone are participating to this talk, I encourage you to share your experience so that the other participants can have more information. I know that there are numerous projects concerning impact of climate change on livestock in arid zone. So I think that this talk can be identified as an opportunity to share experience and help us reinforce the talk. Okay, if there is no one who want to share, maybe we can go forward and after we can come back to some question or some sharing of experience. Like we said, I will present the subsection 4, composed of 5 slides, which are also figure that will interpret. The first is the integrated pest and vector management. The second is with adaptation strategies. The third is about market policy and capacity building. The fourth is about mitigation strategies, and the last is science and technology development. What about the integrated pest vector management? We have the IPVM strategies with disease surveillance and EWS, the climate change impact, and the vaccination program. So those 4 aspects can be the aspect that we deal with to ensure integrated pest and vector management. Concerning the IPVM strategies, we have biological control, the cultural control, the mechanical control, and the chemical control. Concerning the disease surveillance, we have real-time data. We need to collect data at real time so that we don't miss information. Predicting modelization can help us prevent disease and regional system. So we should not work at local level, but have a regional system to cover enough information. Concerning the climate change impact, the distribution changes, how changes are distributed, the abundance changing, and activity changes. So we need to better appreciate climate change impact. We need to deal with both 3 aspects. And the last one is the vaccination program, like herd immunity, preemptive strategies, and tolerance schedule. So if we want to have an integrated pest management, a pest and vector management system, need to take into account at least those 4 aspects. So the integrated pest management strategy focus on biological control, all aspects that concerning the control, the disease surveillance to prevent disease, the climate change impact to better appreciate the impact of the climate, and the vaccination program to prevent disease emergence. What about the adaptation strategies? Adaptation strategies for livestock production can turn around the 5 aspects: climate resilience technologies, yearly warming system, breeding for resilience, livestock management, and diversification. Concerning climate resilience technologies, not but technologies to enhance productivity and these climate challenges. for earlyworm system. The objective is to detect and monitor the climate-sensitive disease. The earlier the disease is detected, the best it is. And concerning the breeding of resilience, we need to have a selective breeding to enhance disease resistance in livestock. So if you want to have a healthy livestock, we need to have a kind of selection to have the best animals. Concerning the livestock management, livestock must be better managed with practice that improve health and reduce disease exposure. We need to clean the area, pay attention to any aspect that can lead to disease or pest emergence. And diversification. The main objective is to have a kind of resilience. So when your livestock is diversified, you can also have many sources of income. What about market policy and capacity building? Many aspects have to be taken into account. The first is the international trade dynamics. We need to master the global market interaction. We also have the management strategies that is an approach is to enhance resilience, the economic impact, where we need to pay attention to the effect on cost and pricing, how both cost and pricing working with time and space. The customer preference, this is important because the projects have to be sold to somewhere, and so we need to have the preference of those who use our products. The governmental policies. Governments need to assist people by regular influence on adaptation, help them to be to have the response, the solution of to be better adapt to changes and technological access, but we'll see how to make available all innovative solutions. Concerning the mitigation strategies, as for the same like the other slide, we have to the institutional and policy changes for climate sensitive stock management that need to take into account the inness of health management policy, the capacity building, the promote climate resilience and the insurance and financial support, the cross-sector policy integration, incentivizing sustainable practices, and strengthening yearly warming system. Concerning the health management policy, we have the veterinary service and the disease services that need to be adopted. For capacity building, we need to improve extension services and conduct training program for promoting climate resilient breeding. We have the support of research institutions and the development of heat stress resilient breeds. We also need to provide private insurance and promote affordable credit access for insurance and financial support. The cross-sector policy integration, we deal with the integration of water management aligned with land use policies. Those aspects must be joined together to have a good integration. We need also to encourage national grazing, improve water conservation techniques. This can also lead to a better management of land. And concerning the strengthening of yearly warming system, we need to integrate yearly warming system livestock in the management of the activity and invest in technologies and infrastructure. What about science and technology development? In other words, how can science and technology help mitigate climate-sensitive threats in livestock? Here we noted 4 aspects. The first aspect is climate resilience breeds, but enhance breeds resilience to heat and disease for genetic advancement. Yeah. The precision livestock farming that utilize technology for real-time monitoring and detect stress and disease early. As I said before, the areas the disease is detected, the area is. We also have nutritional management, in which we need to have the best formulation of diet to mitigate heat stress and maintain health. And the last is disease surveillance and vaccination that will improve disease prevention and control with advanced diagnostic and vaccine. So doing so, we can better contribute to the mitigation of climate-sensitive threat in livestock. So I think this is the last slide of the subsection 4. I will notice for the 2 last session, I decided to comment figure because those figures better summarize what I plan to share for this talk. So, Professor Soro, I'm at the end of my talk. I think that it's the time to share. So we are open for question, contribution, and everything that can be shared to this talk. Thank you. Thank you. Thank you, Dr.
about that thing. I'm not the moderator of the session, it's David. I think it's you have to over to David. He's the one who is moderating the session.
Okay. So I don't know you if you catch me, David.
Yes, yes, Prof. Batin. Are we
Okay.
done with the slide presentation?
Okay. Yeah, I've finished.
Okay. So I think we need to open the floor, right?
Yeah.
So that we get comments, contributions, and any questions from the participants. Today we are finishing much early compared to yesterday, so we still have time.
Yeah.
Discuss.
And some of you had some questions from yesterday. If you have anything you want to ask, Prof. Soro is also here. He can respond. Yeah.
Hello.
Yes, please.
Can you hear me?
We can hear you clearly. This is Lenangosia.
Yes, this is Lenangoisa from Kenya.
All right, please.
So it's just a comment. Thank you so much, Prof, for the presentation. So in Kenya, one of the programs that we are running is a program to capacity build pastoralists on some of the practices that Prof has presented, and I'm really happy about this presentation and looking forward for Prof maybe to share the presentation with us. One of the things that we are doing is that we are training pastoralists on matters on breed improvement, keeping adaptive breeds like camels and goats. You know, effect of climate change comes like in 2022, there is a huge drought that has stricken the northern part of Kenya. And pastoralists have really lost their livestock. As we are speaking now, there are plenty of grass all over the landscape, and we have less animals. As one of my friends, I don't know, it's from Zimbabwe or from where, stated that number of livestock has really reduced because of the effect of climate change. And one of the things, or one of the deliverables that we are doing as the people in the field of livestock production and veterinary services, is providing extension services to the pastoralists at the grassroots level. You know, the government is there, but you know, the people are down at the grassroots level where there is no access to roads and infrastructure. But all these NGOs, one of the NGOs that I work for is that we go to the village level, help people, do extension services, tell people about the scenario warning, the early scenario warning, the drought, effect of maybe diseases, the importance of vaccination. One of my friends from Kenya stated the issue of vaccination. In Kenya, we are doing mass vaccination. This is just to curb the effect of diseases, and also to meet the export market. And one of the things that I want to ask, maybe I want to ask Prof, what is that thing that we need to do apart from using chemicals in the field of livestock production? You know, there is this big global concern of antimicrobial resistance. What should we do to reduce the cases of maybe using chemicals in the field, you know, pastoralists using chemicals? How do you now control factors, for example, those that transmit trypanosomiasis? How do you control factors without necessarily using chemicals? Is there a biological way of introducing, for example, a gene that will affect the prevalence of a given factor in an habitat? So those are some of the things that we are doing. And I'm very happy about the presentation. Looking forward for the slides. Thank you. Greetings from Kenya.
Okay.
Asante sana, thank you.
Thank you very much. I was in Kenya 4 months ago, and I really appreciate your country. Thank you for your contribution. To go through your question, I think that we need to make a kind of ethnobotanic studies, because in the farmer, I really know that our ancestors have their own way to treat the animals. We have a colleague here in Cote d'Ivoire who is promoting a kind of biopesticide. I think that we can also investigate with this way, because we have all the good plants in Africa, but we can use those plants to to extract the chemical active to promote biopesticide. The first way I can solution I can suggest is the promotion of biopesticides, which have low impact. No impact on the environment. Do I make sense?
Yes, Prof. Thanks.
Yes. Yes, can I just add concerning this issue of biopesticide? Just at the same line.
Yeah.
Hello.
Yes, please
yeah,
go ahead.
Yeah, it's Dorothy Chachwa Dorothy from Cameroon.
Yes, Dorothy.
It's Dorothy from the University of Arua, Cameroon. Yes, I just wanted to add information of biological culture. I think that system which we are like going into, we just like stop using anything in our agricultural system. We are just going out in plant production, in animal production, in such a way that we just use our natural product. I mean, for that was because we did all. But today, because of the overuse of chemicals, our environment is destroyed. So we are thinking of going back to our natural system, which is the biological agricultural system we want to introduce now in our agriculture production and plant. The agroforestry system is part of the biological agricultural system, where animals plant integrated in the system in the same environment, so that you can be from do the plant production. Everything is bio, as they will say, to producing our forage or the grass that we are using should be biological. I think when everything is biological, grass, the disease treatment, the feedment, all they eat, the animals are through the biology or using mineral fertilizer. I think that's just what we are doing, where we use just natural fertilizer, the production of even the animal feed, mostly grass that the animals feed on, forage that the animals are going to feed on. I mean, the integration agroforestry system, where you mix agropastoral system, where you plant animals together. I mean, the system that will the climate effect can be mitigated if properly handled. That's just my contribution.
Okay, thank you, Dorothy. Communication was not very fluid, but
I think it
think
was
that,
breaking, Dorothy.
yeah.
I didn't
Yes,
get it clearly. Is it possible, Dorothy, you type also on the chat so that we can capture it? Thank you.
Yeah. Thank you, Dorothy. Thank you for your contribution.
Okay. Anybody else?
Yes. Yes, sure.
Oh, yes, Professor. Please move near the microphone so that we can hear you clearly.
Okay. I move this. Here is. So what I would like to ask is now. Is it okay now?
Hey, it's very okay now, Prof.
Great. Thank you. I just want to know, since we have a lot of specialists here, which climate-sensitive disease do you believe are currently the most under-researched but pose serious threat to livestock in sub-Saharan Africa? And my second concern is how can cross-border collaboration be improved to tackle transboundary disease like trypanosomes or East Coast fever? Here are my two concerns. If I can have a beginning of answer, it's gonna be great for me. Thank you, David.
Thank you, Prof. Prof, I think we have a lot of experts here and animal scientists from different parts of the continent. I think they can attempt to answer your question. I saw there was somebody from Namibia, I think also. So we have some animal science experts around. They can help us.
Okay, until we have someone to give an answer to Professor Soro's question, I'm very autonomous with the second question. For the second question, I think that this question is more for transhumance activity. So what I would suggest is to have a unique policy for to manage transhumant animals. For example, when we take the case for Côte d'Ivoire, animals come from the north, precisely from Burkina Faso, from Mali, and I think if we want to face this issue, I think that both countries have to work together and try to have a common policy to manage the activity.
Thank you, Prof. From my side, I also think that we have some framework engagement that are currently implemented, especially among the sub-regional research organizations like CORAF. They probably have mechanisms whereby they ensure that their member countries work together to manage some of these cross-border issues like the cross-border diseases. I mean, another example is the one in SADC. They call it CARDESA. It's one of those agencies that is actually responsible for coordinating research and extension activities. So I think even them, they have a framework whereby they work together, and it's really led at the highest level. They have a council of ministers who make policies relating to agriculture, trade, and different sectors. So I think there are already some some structures in place, but maybe I think we need to strengthen them to just make sure that there is good synergy in terms of the way they work. But I think we need to listen to some other experiences from other participants if they have.
Yes, I think you are correct. You are right to say some countries, especially in Southern Africa, in the SADC region, but we have strengths in the wildlife where we have Mozambique, Zimbabwe, and South Africa working together in terms of wildlife, Botswana, Zimbabwe, Zambia. So I think if we can also do the same with the livestock, I think it can work out in terms of disease control.
Okay, thank you.
Okay, thank you.
For my first question, about the most serious climate sensitive disease, but for which we don't have enough activities of research.
Prof. Soro, we didn't get it. Maybe you can again move a bit closer.
I was asking if you have. I was asking if you have some attempt of answer for my first question about the under studies climate sensitive disease. I mean, you know, there are some neglected disease in human, but for livestock, I think there are also some of them. It's such disease I would like to know if there is a kind of this thing with livestock. Neglected disease, but which is have a great impact on the livestock. Do you get me?
Yes, Prof, we've got you actually. I think let's hear from the animal scientists in the room.
Anybody want to?
Anybody willing to give a suggestion or a contribution?
I just want to know if there are some neglected diseases in livestock farming.
Hey, Prof. Soro, seems like we don't have many animal scientists here.
Hello, David.
Yes.
This is Steve from Kenya.
Yes.
Kindly, I wanted you to repeat the question because I didn't.
Please, no sound. I cannot hear anything.
David,
For
can you
us,
hear me?
we can hear you. We can hear you, Theo, actually. So it might be his volume. Kindly check on your volume settings.
Oh, my volume or Prof's volume?
Maybe Prof's volume. For Theo,
Okay.
it's okay. Yeah.
So, David, what was the question?
I think that to resume, Professor Soro want to know if we have a neglected disease in livestock.
Neglected.
Yeah.
understudied? Do we have diseases that have not been studied much, and yet they have a lot of impact on livestock?
Yeah.
That's his question.
Yeah, thank you, Prof. Lamte. Seems we are not getting any responses. Maybe Prof. Soro and the team. I think we have very few animal scientists here. But at least myself, I studied a bit of animal science in my undergraduate. And usually people know the common diseases that really affect the livestock. For example, this East Coast fever, this one which is transmitted by ticks. Then you have the common one, foot and mouth disease, which is dangerous and can also be transmitted by humans to livestock. So there are some of those few that we know, but I consider them common, really common diseases that affect livestock. I'm not quite sure about those that are really neglected in terms of epidemiology studies or something like that. Okay.
Yeah, they are there, but I think the challenge is that we don't pay much attention to diseases that are not affecting our livestock, or that are not affecting our socio-economic status. I think that's the challenge which is there.
Hello.
Hello.
Can you hear me?
Good afternoon. Yes,
yes,
good
please.
afternoon.
This is Timpon, right?
Yes, from Nigeria.
Okay, please go
Hello?
ahead.
Like in Nigeria, the common neglected animal disease, like we have some of them like anthrax, which is a bacterial disease, brucellosis, which is also a bacterial disease that cause abortion and infertility in our livestock. Then you also have bovine tuberculosis and even rabies, like which usually affect cats and ducks. Then FMD, which is foot and mouth disease. These are some of the common diseases that are neglected in Nigeria, even Newcastle. Thank you, sir.
Thank you, Timpon, for your intervention.
Thank you for your contribution.
Okay, sir.
All right, participants, I think we are left with 4 minutes, then we close. Today we need to end on time. I've sent a registration link on chat. Please register before the end of the meeting so that we can, So let's welcome maybe 1 or 2 more questions and we can end the session for today.
Hello.
Yes, please.
Can
This
you
is
consider?
Lenagosha, right?
Yes.
Please.
Can you consider snake bites as one of the conditions that are neglected?
Hello?
Yes, Prof. Batin, snake bites also an issue in your country.
Come again?
Sorry, I'm saying snake bites can be considered as neglected because in most of the areas, maybe doing research on snake bites, it needs a lot of resources. So most probably we should consider them as part of neglected conditions in the landscape, because most researches that are being done requires resources for them to be successful. You know, for example, in our country, there are cases of anthrax, but you know, once the vaccination is being done or done before the occurrence of the disease, I think we don't consider them as neglected as such, because we just do vaccination before that. And once you control at the earlier stage, then absolutely it will not occur. But cases of snake bites is not easy because there are minimal researches that has been done on it, especially epidemiological research.
Okay, thank you. Here in Cote d'Ivoire, the only case of anthrax I hear about it was on wild animal, precisely on chimpanzee in Vitai National Park. Apart with, I haven't heard about anthrax in livestock. Maybe it exists, but I don't have the information. But I know that on chimp in Thai National Park, we detected anthrax on chimpanzee.
Hello, can I ask my question?
Yes, Angela, this is now the last question before we close. Please go ahead.
Okay, Angela from University of Nigeria, Suka. You were explaining about the adaptation strategies, and you mentioned market and policy and all that. But the issue of that market, you talked about international trade. What? I didn't get how it can help. The issue of market, how it can help to reduce or mitigate the effects of climate threat diseases. So just explain it to me again. Thank you.
Okay, thank you. I will take the case of Cote d'Ivoire. You know, our country is not a very important country in livestock management. So the most important stock of livestock comes from Mali or Cote d'Ivoire. So if we don't have a common strategy to mitigate, to organize, to better organize the international trade, we can better face issue related to livestock. So that's why we suppose that having a good international trade can also help mitigate climate change, because both animals have an impact on the environment, and the environment also have an impact on the animals.
Okay. Okay, thank you so much.
Oh, okay, thank you, Angela. And I think, Prof. Batin, we need to end here for today. We still have some 2 days left, so I think we shall have still enough time to continue our engagement. So on behalf of the RUFORUM Secretariat, we thank you all for your participation. We thank our facilitators, led by Prof. Soro, and today's facilitator, Prof. Batin. Let's meet again tomorrow. Please come and we share different experiences and knowledge from around our continent. Thank you very much.
Thank you,
Thank you,
David.
bye.
Thank you, everybody.
Thank you, merci.
See you tomorrow.